we'll definitely get into. For those that don't know, Nexar is a provider of real-world intelligence and a really powerful layer for real-world infrastructure. We have over 350,000 AI-powered dash cams that are all throughout the US. You can almost think of them as computers on wheels with all types of different sensors that are understanding the world in real time and providing really valuable insights to all types of different stakeholders across the automotive and mobility landscape. So excited to dive in today.
And then Nick Allen with TaskUs, we are the head of AV and mobility solutions. TaskUs is the human-in-the-loop factor that is supporting 8 autonomous vehicle companies today across robotaxi, autonomous delivery, as well as freight.
Fantastic. Thank you all for being with us here today in Detroit, Michigan on this beautiful, rainy day. So just starting off, we hear a lot about self-driving technology and impact over the next decade and what it can do. What perception of safety technologies are already making roads safer today? You can see out there a lot.
Is that directed at me?
Whoever wants to take it.
Okay, I'll give it a try. So I think connected to the perception and safety and sensor technologies that are being deployed not only in autonomous vehicles but also ADAS systems, video telematics, fleet management systems. The technology has come a really long way. I want to pivot the question a little bit into something that might seem really specific, but my observations across pretty much all industries have provided a really interesting signal to me around not what is the most important tech at the moment, but what is the most important data for these different industries. A lot of times, regardless of the industry that we're talking about, the signal for safety is crashes, it's accidents. And what we've seen in working with our partners in the autonomous vehicle industry, our partners in departments of transportation, is that they're actually looking for a different type of signal, a different type of data in order to do all types of things. And essentially what they're looking for is near misses. To explain it very simply, a near miss is exactly as it sounds. It's when a driver avoids an accident. It's a little bit hard to define very specifically because, is a fender bender a near miss? Is a really harsh brake a near miss? But let me talk a little bit about why I'm bringing this up as the first question and why near misses are so important. First, starting with the autonomous vehicle industry, you might think of the edge cases and the types of scenarios that AV companies need to train their models as severe accidents, right? They want to understand accidents and learn from them. What we're actually seeing from our customers is they want to see the scenarios that are really dangerous, but that drivers were actually able to avoid in the form of a near miss. And the reason that this is really important for them is because they want to be exposed to those really dangerous events, but also learn from the behavior of the drivers that were able to avoid the accident. And then they're able to take that behavior and teach their models accordingly. And so more and more the work that we're doing with AV Labs is in the form of, we want to understand drivers that are in really dangerous situations and how they navigated those successfully in order to train our models. Another really good example is for departments of transportation, a proxy for understanding where there are dangerous intersections in the past has traditionally been where are the most crashes happening. And this ultimately is a lagging indicator, right? By the time that you understand where the most crashes are happening, it's too late, the crashes have already happened. And so one of the key pieces of data that departments of transportation are looking for is understanding, again, where are drivers avoiding collisions at mass? What are the intersections where consistently drivers are avoiding severe accidents? Because if you can identify those clusters, you can take the driver out of the picture and attribute that something dangerous is happening in the environment. So maybe these near misses keep happening because there's a really bad pothole, or there's a construction crew that's operating at night when they're not supposed to, or there's a stop sign that's covered by a tree and people keep jamming through it. So this is one insight that I found really interesting recently, and I think it just speaks to how advanced our industries across the spectrum are getting in terms of the data requirements that they have.
Does anyone want to build on that on perception safety technology that's already on the world today, or build on John's point around what data is being collected, building matters, looking at this?
Yeah, so to John's point, a lot of the data is being captured through the network you have today. It's available for use. But I think another area is organizational readiness to take that data and make use of it. So how does the Department of Transportation actually use this in the day-to-day to make the roads safer? It's there, which is great, but if you can't utilize it, then it's just data to sit there and not serving a positive purpose. So it's that organizational readiness that needs to be focused on.
I'll also say technology that's in place today is eye monitoring systems. So we built this into our safety framework across our fleet operators and market as well as remote assistance. And it's monitoring not only the distraction, but the fatigue management that's coming into play to provide early identifiers so that we can engage either with the driver or the remote assistant ahead of time to ensure that safety is number one. How are they getting, what is their overall physical wellness and mental wellness, and then being able to have that conversation ahead of time before a safety risk takes place, and then we're reacting to the situation instead.
And then I see how you're taking the mic. You want to add that? Or
Just really quick, just to make a quick distinction. So for us at DoorDash Labs, not sure how many folks are familiar with the work that we're doing, but we've been in existence for about 7 years. We've been focused on autonomy and really how we can impact our customers and merchants using robotics. And so the first question we looked at is whether or not sidewalk robots could really be helpful to our business and be impactful to the communities in which we serve. And we found out the answer was yes. But in doing that, we found out that in developing our own robot, we could really meet the unique needs to DoorDash. So just a little bit about DoorDash. We are doing 8 million deliveries a day. A significant portion of those deliveries are occurring in the bike lanes, and so we are using delivery workers who are on e-bikes, scooters, bikes, and what we realized is that we could actually have an impact on safety by removing the robot from off of the sidewalk and placing it into the bike lane. And we found that that has worked really well. We've been testing in markets like Arizona for the last 7 or 8 years. Since unveiling our robot, which is called DOT, we've deployed in other markets in California as well. We recently announced Fremont, California. But I say all that to say that you had existing technology, you had an existing sensor suite that was primarily used for autonomous vehicle technology. You had your cameras, LiDAR, radar, and what we've been able to do is really leverage that, put it on a purpose-built robot, and really advance this industry, what we call personal delivery devices. And so today with DOT, you have the most advanced delivery robot there is. We're using bike lanes. We are traveling at speeds up to 20 miles per hour, which is truly unheard of, truly unique to what we're doing here.
Fantastic. And touching a little bit more on something that John brought up around what do you do with the data. Can you guys talk a little bit about what data is helpful to pass on to policymakers, DOT, so they can make informed decisions of building out infrastructure, roadways, sidewalks, highways. Talk a little bit about that process. What that looks like.
Yeah, absolutely. And I think this is a topic we've talked about in a number of different urban autonomy summits, is how do we improve the public-private sector dynamic relationship. And I think there is a little bit of a misconception that there's maybe a lack of willingness to collaborate, to share data. My observations is that that's not actually really what the problem is. My observations are that everybody here today, that we have representatives from public sector, private sector, large institutions, startups, middle-sized companies. Everybody's here because they have a common goal of advancing their specific institutions forward and ultimately getting to a place where the roads are safer. So to me, it's more a conversation of how do we set up a the right frameworks in place to allow for companies and institutions and governments to partner together? How do we organize the right forums so that the right dialogue can happen? This is a great example of it. And 3, how can large institutions and small institutions partner in a way that gives smaller companies the opportunity to put their technology in front of governments? Because I think, again, from my experience, the public sector wants access to the latest and greatest and the hottest technology that's going to make things more efficient, that's going to make their roads safer, that's going to help them optimize their budgets. For us, a great example is our partnership with IBM, where we saw in IBM that they have incredible infrastructure for engaging with the public sector. They saw in us that we have a really valuable product and asset, and so we've partnered together in a way that allows us both to get in front of those public sector stakeholders and showcase opportunities for us to work together. And so I think there's a lot of data that can be shared. There's a lot of different ways that the partnership can happen. But from my perspective, the key for all of us is to be setting up those frameworks and organizing those forums for the conversations to happen.
I think so from a data perspective, the ability to communicate back with the municipalities about road work that needs to be done, such as potholes, being communicated back, or even on the robotics side, where ADA cutouts, curb cutouts are not in place and need to be adapted for certain areas of the city. Now, on the policy side, there's a lot that needs to be done from like communicating the safety frameworks as well as the reduction of fatalities that are coming into play to help policymakers build guardrails, not force isolation. If we can get into a federal framework where at least there's a set of rules for everybody to follow, that'll help with the innovation that's coming into play, accelerate what everybody here is trying to do, but also be able to advance those technologies in a quicker manner to get out to a larger population across the states.
What we're finding is, we're talking to a number of cities about where that will ultimately deploy, and I must say that these are wonderful, fruitful conversations. I started my career in the AV industry working at Cruise back in 2017, and I think at that point, we did have interest from some companies in wanting to share data. They didn't want to be first, right? I think the conversation has shifted dramatically on both ends, on the operator side and the city side as well. On the city side, I'd say there's more an openness to flexibility and a willingness to hear operators out about certain constraints around sharing data. So perspective that we often share is that, we do want to share data. We want to make sure that data is accurate and that it's actually helpful. And so conversations in those directions have been happening and have been pleasant, I think. In terms of specifics, I agree. The frameworks need a lot of work. And I think that for technologies like ours, where it's very, very local, that conversation has to happen at the local level.
So when I think about the data, there's the training data that can go into making better decisions in the future, but there's also the production-ready usage data that a Department of Transport agent could use to identify problems that might be more manual today. To your point, there's that element of, can we trust this data? Can we really let it go and do things without having a human in the loop, which at this stage I don't think we're there, but there's that kind of early practicing of trying it in a limited format that will gain trust and start using these models to solve more problems. When you think about the 350,000 cameras that are deployed through the Nexar system today, that's giving every Department of Transportation agency employee access to all of those eyes, things that just would not be possible through humans alone. The agencies can't scale to that limit. So using the technology and that data that's generated to put into the production workflows, I think is an overall better safety story.
Yeah, if I could just add one thing, and I agree with everything that's being said, specific to the AV industry, I think there's a general, and I think it's a warranted concern from the AV companies, since they're dealing with such a highly sensitive asset from a safety perspective, is that when they share the data, whether it's to a regulator, whether it's to their insurance company, regardless of who it is, they don't know how that data is going to be interpreted, right? So the worst thing that can happen for an AV company is they share all this data with the regulator, they don't have visibility into the evaluation framework, and the interpreter spins it in a way that makes the AV company completely blindsided and look bad. And so I think what we really need to work towards, especially in the AV world, is what does success look like? What is the standardized framework for evaluating performance? What do giving AVs the clear transparency in what they actually need to achieve in order to deploy on the roads, in order to get insured, in order to expand. And I think that's what's lacking today is for the AV labs, they're a little bit blind to what's going to be actually done with the data if they turn it over to the specific stakeholders.
Sorry, just to that point, and I think that's an excellent point. One of the things that we've seen is just resources, right? The operators need resources to share data and make sure that data is accurate, but also cities and states need resources on that end. And what we have seen is that there are certain areas that they would love to receive data from us. They just don't have the personnel or the budget to hire folks to really do things with the data. So that's another concern.
So we kind of covered, the data aspect, the policy aspect. I want to talk a little bit about just interacting with humans that are seeing technology sometimes for the first time, when they see that for the first time, or maybe on the road, and as we scale technology scale up, how do we nudge the human drivers or seeing back where their vehicles or interact with new technology that they're seeing for the first time?
You're probably best to start us with this.
I think early education is probably the best. So from a go-to-market strategy, as you're coming into play, the first thing that is trying to be understood is how this is going to be applicable to me. How do I get engaged with it? And also, how is it going to be interactive with an engagement perspective? So the educational value is number one, I think, what needs to take place going into new cities. And that's across the robotics side as well as the AV side for road taxi and freight. Because obviously you have to have different interactions, different requirements for all of those modalities. The other ability is to try and get as much public access to the technology as possible, because the first time you ride an AV, it's exciting for about 10 minutes, and it gets really boring, which is exactly what's supposed to happen. But it's that first nudge of getting somebody into the AV that I think is the hardest step, is accepting that they're not in control, but giving that purview that we do have other individuals in control as the technology is developing, as it is advancing, and then perfecting itself to really be able to address 99% of the world, but also how it responds to edge cases in the future.
It might be weird to say, but I think it comes down to the trust in the systems. And a lot of people don't have the trust initially with any new technology, especially something that is potentially puts your life on the line. And so doing these kind of small incremental wins, driving that, showing up successfully every day over time, drives more trust, and people like to use these systems more and see the true value out of them.
I think another sort of emerging trend in the industry that you probably know a lot better than me is you read articles about OpenAI and Anthropic that are entering into these massive engagements with some of the most prominent consulting companies to help them actually deploy their technology into institutions that want to be on the cutting edge from an AI perspective, from a technology perspective. But the reality is implementing it across 5,000 employee, 10,000 employee organizations in a structured way, in a compliant way, in a privacy-first way is really, really difficult. And so I think we're going to see a massive continued growth trend of these really fruitful engagements where companies that are experts in implementing this technology partnering with the institutions that need to use them.
Fantastic. I think we have time for one more question if my time is correct. So if a company is operating at scale, what's the insight to emerge from those real world trips of highlight some of those challenges in the room today.
Thank you, sir. I think in its simplest form, simulations are great for testing, but they're limited by their inputs. They're limited by the data that flows into them, and they're limited by what they've actually seen in the world. And so where like simulations have a ceiling is when there's a deer crossing the road in the middle of the night, in the middle of Wyoming, in the snow, right? The simulation has never seen that exact scenario happen, and so you can't accurately test against it. And I think that's where the need for real-world data at massive scale that covers the extremely long tail of edge cases is ultimately the main thing that's going to enable AV labs to accelerate towards mass market adoption. Because while these edge cases are only a very small percentage of what happens on the road, they're actually a very high percentage of when accidents happen. And so in order for them to deploy in a fully autonomous way, you need to be able to prove that you can handle that deer jumping into the road in the middle of the night, and simulations are just less effective at doing that.
I'll say the other thing that the simulator can't replicate with millions of miles of data is the interaction with humans. So like from a robotics standpoint, you can follow how the code is going to respond, but then actually having an engagement with a human who's walking a dog on the sidewalk, and what does the robot need to do versus what does the simulator think about. The other side of like the robotaxi piece is the localization training, as well as how local societies are going to be engaging with the technology. Because how our teams in Texas and Arizona are operating for remote assistance and safety driving is completely different than how our teams in Japan are operating. There is a standard foundation of safety that's built into it, but the way that communities are engaging in their normal daily drive and how humans are interacting on the road cannot fully be replicated on the simulator, where it can follow its code exactly, but what happens when an interaction occurs that's not optimal, and what is the robotics going to do, what is the AIS going to respond with, and doing that at scale now for the last 9 years has allowed us to see everything across the board and be able to help those models get trained, but also push it to its limits and really be able to understand it.
For us, we've learned a tremendous amount in testing for sidewalks and then realizing that predictability is really important and you can get more of that in the bike lane. We've designed that to behave like a cautious cyclist, and so for us, every single delivery is a new learning. I think what's important is in terms of building trust, more local engagement, and then sharing, out how we're actually learning. And so those are the things that we're doing now in many markets around the country, and we're finding a lot of support from cities because they're actually understanding how we improve our behaviors in real time.
It looks like we actually have time for one more question. We talked about a lot of safety metrics today and data. Well, what is the most valuable safety metric that isn't getting enough attention today? Not talking about near misses, not talking about perception, but what have we not touched on today that Kathryn was aware of?
But maybe a slightly contrarian one, but a number of people using the AI-assisted tools to drive more safety. Right now, I don't think we're tracking the number of department staff who are using AI tools outside of chatbots to get answers, but in the actual day-to-day workflows of an issue pops up, somebody goes out to survey the area, there's a punting issue, or some things that might cause safety issues on the road. I don't know if that's being measured today, how that is being augmented, and in some cases becoming more autonomous.
I would also say time to resolution. And what I mean by that is when an edge case happens in the public, it is viral. And there's a lot of visibility into what occurs and what happened and what should have happened. But the ability to show how quickly resolution is taking place to those incidents and the models that are being trained, the amount of time that's being put into it with the teams and being able to communicate out to the public of, this happened, here's how this is developed, here's how it's gonna react in the future, and then even showing examples of it. That time resolution, I think, would be pivotal if it can be shared out and knowing that this is a top priority for all AV companies and how they're reacting to it and putting their time and effort behind it.
Okay. Deaths. I think we talk a lot about safety, and we hear that number all the time, 2 million deaths globally that happen from road accidents. And I think if the industry at large truly believes that the path to making material progress on deaths that happen on the road is autonomous vehicles, then I don't think that the industry is doing enough to move fast enough. If you think about where we are, especially compared to the growth of digital AI, think LLMs and chatbots that everybody uses every day at this point. We've been working on autonomous vehicles for 15 years, and the last 2 or 3 years have been a massive inflection point. I mean, Waymo is growing like crazy, so many others are coming out of the woodworks. It's awesome, but in the grand scheme of things, the deployments are so small and they don't actually make a dent in the footprint relevant to the amount of human drivers that are on the road. And so if we actually believe that AVs are the path to reducing the amount of human deaths, then we need to figure out ways to drastically speed up the pace of deployments, because at this rate, it's going to take a really, really long time for every single vehicle on the road to be an AV.
I think that's a great call to action for everyone and good motivation. And so if I can give this panel a round of applause. Thank you so much.
Thank you guys.